So welcome back. Like I said, we will break these whole, the live lab into multiple parts. Even it's a long stretch home, we will continue to do justice to how we manage this lab, right? Till now, in the previous two videos, you would have seen the basic components of Kubernetes clusters on both these M1 and M2 clusters. And now with the last video, we deployed Kube Vault on M1, which is Vault as a service. And then we deployed secrets operator on M2 and then fetched the secrets from Vault and made them available in the SockShop namespace. Like I said, we had to patch these secrets with the labels, and we have done that. So now if I look at the secrets that I have in M2 cluster, so we are on M2 cluster, let's validate that. Yeah. And if I look at the secrets in the SockShop namespace, we can see that there are 5 secrets made available to this namespace. Now is another interesting conversation, bringing in KubeDB, the second product from AppSport, into the mix. What is KubeDB? What does it do? Tamal, over to you.
Sure. Yeah, so KubeDB is a database operator or collection of database operators for Kubernetes. So you want to run or deploy production grade databases, right? It's not provisioning, setting up monitoring, setting up backup, setting up auto scaling, setting up TLS, all those aspects of the database management, lifecycle management. The operator can do it for you. It's all done through the standard kind of Kubernetes custom resources CID based interface. So it's all declarative, and you can, if you want, like you can use GitOps, like you can add auto CD or plug CD to it. And we have support for quite a few databases. I mean, all the common ones that you would expect, like Postgres, MySQL, Redis, Mongo, Elastic, OpenSearch, and then some of the other connection pools type of things, right? So it's a growing product, and can manage all aspects of your database management. That's kind of the vision we have. So we're working towards that. Yeah.
Do you think people will ever move away from RDS?
Yeah, I mean, our users are actually doing that. I mean, it's not necessarily move away, but it's kind of, once you start, cost becomes a factor, right? Like, and then a lot of times people are doing a lot of different types of flexibility, right? Like you want this extension, that extension. And then typically people will have this kind of we see a lot of like a hybrid environment. So okay, some of it is on cloud, but then some of it is on-prem, and that's kind of places it really becomes useful, because then you have like one single stack that you can take on cloud or on-prem and use it, with changing maybe a few things like the storage class and stuff like that. But so that's where your whole workflow, right? Like this whatever, like Helm chart or customize whatever you are using to deploy these applications, you can use the same stack everywhere. Your developers can do it, and that's kind of where something like a KubeDB becomes very useful, because it's one stack, it goes anywhere. And if you're on cloud, you can use it in cloud. And at this point, we have in terms of feature parity, right? It's pretty much anything you can do, let's say with RDS, you can do with the KubeDB in terms of the sort of the feature set. So there is no like, and it's better tested, which is another thing we would say. So you can run it without any worries, databases, right? Because databases are very important, right? So for any organization. So yeah.
So what we will do in this particular part of the lab is we will deploy KubeDB operator to start with. Like I said, it's an umbrella project, the operator, to deploy and manage many different underlying databases. Like you just saw on the screen, a plethora of options, and growing as we see the future. To deploy the operator, we will now KubeDB itself has a licensing requirement, which is different than Kube Vault. So like that we did the last time, I am going to switch to M2 cluster, which I am already on, and I'm going to run a script which will help me get to the the license server, retrieve the license, and then work with that license to install the operator as such. Okay, so let me go ahead and deploy the licensing. And for that, the script will ask you, again, this is pretty much standard stuff documented on the apps code website. I've just scripted a few lines here and there, just kind of make my life easy. Cluster name is M2. My name is Amber. My official email address. Then what we have here is basically the licensing. You can see this particular license key, M2 KubeDB license key.txt. So this is the license that is generated from the API call. Now that I have the license, we can work to deploy the operator. And let's do that. The operator can be deployed through a Helm-based standard affair. And I have mentioned that it should be deployed in the namespace of its own called as KubeDB. And with this as the license key, which is the cluster name, which is M2, and then the license key. Let's go ahead and deploy this. Okay, so while this is being deployed, I'm also going to talk to you about what next, which is we have Prometheus and Grafana already installed. There is a project called as, I don't know, Tamal, you are the better, how do you spell it?
Panopticon. So, right. I mean, if I can give you the context for the project, which is that, like, when you are using the Kube Prometheus stack, one of the important component is the Kube state metrics, which is kind of, takes all these Kubernetes level resources like deployments or pods or nodes or stateful sets and expose various metrics for them. So we tried to do the same thing, but something that can work for CRDs. So this Panopticon is essentially like think of like a state metrics for CRDs. So for these various CRDs that you would see, let's say Wall Server or like this KubeDB, Postgres or MySQL, things like that, this can essentially expose metrics, things like, if it is up and running, what is the sort of, is the database is ready or not, like, those kind of things. Then you can essentially expose it to your Prometheus instance, and then from there you can, build Grafana dashboards, all that standard stuff.
Got it. So a very nice piece of abstraction and helping this, from a end user observability. It's a very important piece of linking KubeDB with, Prometheus and Grafana. So for Panopticon, there is no separate need for a license. It can work on the same KubeDB license key. So I'm going to use the same license key, okay, and take this particular set of commands. I'm just going to make sure that I copy them rightly. And I'm going to install Panopticon. So I can see that this is done. Let me verify, get pods, -n, KubeDB. So you can see that a few number of components are running, and each one of them has an interesting role to play. I've still not installed Panopticon. The provisioner is the key and the heart of it, right? I mean, that's where the whole action happens actually.
Yeah.
And then you have other things, going on. Why don't you, brief us a little more, Tamal, on these?
Sure. I mean, usually, typically, we try to name it based on the kind of the functionality of the component. So as you already mentioned, provisioner is the component that will, provision the database, right? So whatever type of database that you try to provision any of the supported database types, that will be done by that component. And then there is the webhook server. So this is the, if you're using this Kubernetes validation and mutation webhooks, that's where that's the component that does that. And then there's the ops manager component. So this component to do all the sort of the day 2 operations. So in KubeDB, we have this concept called like an ops request. If you think about, like, let's say you have a Postgres running, right? And at some point you want to maybe, scale it up, the vertical scaling. In a typical like a deployment, what do? You just go and maybe just change the resource and get all these pods up and running that way. But when we look at database, at least it is our opinion that you should not really do that in a database, because in a database you cannot just randomly restart pods, right? You have to do this in a particular order to reduce like the amount of downtime, because you want to reduce the number of failover that's needed in a, let's say, a high availability Postgres instance. Plus, if something goes wrong during that process, right, you want a place where you can go and see what actually went wrong, right? So this ops request type of approach kind of gives you that option. So you create a request, and then that you can actually kind of observe the status for that request object to see how things are going, how much of it is done. So that's the model, and that's what this ops manager component does. And then we have the auto scaler component. So this is actually a recommendation engine with the auto scaling. So this is the internal recommendation engine is based on top of the Kubernetes VPA, the vertical pod autoscaler. But one of the interesting thing about databases is that in a typical Kubernetes environment, when you scale a pod, you can just scale a single pod. But in Kubernetes, when you are scaling up, let's say you are running this Postgres, your master instance or the primary instance has all the load. But when you scale it up, you should also scale all the standby ones, because whenever the failover happens, if you don't scale all of them, you'll immediately have an out of memory kill situation, right? So that's why we have kind of taken the core recommendation engine that comes from the the VPA project, but built up that, okay, when you have this kind of, it is database aware, right? So it knows that, okay, if it has a collection of pods as a group, then when it scales up, it needs to scale all them up and all that. So that's kind of what this autoscaler does. And then we have a dashboard component. So this is actually more for specifically to like Elasticsearch. So the Kibana dashboards, if you want to provision those, that's where it comes in handy, and it can does those things.
Yeah. Fantastic. I think there are some very important takeaways, right, from what you just mentioned. One, having a playground of Kubernetes for showing off some YAML and some, it's a very different. Yeah. But if you're getting serious about running enterprise workloads and especially databases, you got to build a system that manages that kind of beast mode. And this is true particularly of large-scale databases and the complexities that go hand in hand. These are stateful. Yep. And that word is not out there in the market for for loosey-goosey usage. It's there to define what the attributes of this engine are. Stateful has a connotation to what the primaries would be surrounding the context. Now, we can have, like you said, just a YAML, increase the resource, increase this, increase that, and have Argo CD pick up those changes in the YAML manifest, deploy that. I mean, who cares? I'm just here to show a demo. That's not how real applications work in the real world. I mean, you've got to sequence it out. And that's where I think what KubeDB has been doing into making sure that the sequencing, like you mentioned, right? I mean, all those complexities are considered, and I'm pretty sure your job's not done. As you get more experiential with what's happening, these things will continue to. But what I like about this whole thing is your commitment and investment to making an enterprise grade operator come true, and that too as an umbrella, not one operator for Postgres, one operator for, I mean, there are beautiful solutions out there, but having that umbrella and a common paradigm kind of attesting itself to so many different databases. So that's the beauty I like. Thanks from the community again from my side.
Thank you. I mean, thanks for those kind words. I mean, one of the things that I would like to mention in this context is, I mean, if when I talk to a lot of folks, like out there is still this sort of idea that, okay, I can run my databases with Helm charts. Maybe I have this, Bitnami Helm charts or stuff like that. This is where, again, this thing comes into play, right? Like on a day one, right, you just provisioning your Helm chart database with the Helm chart, it works fine, right? Like you provision it, maybe you get this dashboards, Grafana dashboards from their website, it all works fine. But the moment you start thinking about, like, what happens in these day two scenarios, that's when you're you are essentially manually pushing the knobs what this operator is doing, right? Like you want, okay, I have a high availability Postgres deployed with the Helm chart, but now I want to increase the PVCs, right? Because my disk is almost filling up. And now what you have to do if you're doing it manually, okay, I have a stateful set, so I have to like a kill a pod, increase the PVC, then bring this up, like all those things. I mean, and if you have a real environment, let's say 100 gigs of data or more, or 500, like now it's the potential to make a mistake on a critical system is very high, and frankly just a lot of time wasted, which is really the value, right? So that's where something like an operator based system really starts to shine, because now you have this sort of process or this this application that is relentless, right? Computers doesn't tire, it doesn't make mistakes as long as we work out the bugs. So it can keep doing these things again and again for however many databases you have, however many clusters you have, however many times you need. And as Kubernetes versions updates, like there is always this slight changes that happen, so we make sure that those things are taken care of. And that's when I would say, like, if you are really serious about running like a database type of workloads on Kubernetes, Helm charts are not enough. It can be good enough for a demo or just getting started, but eventually you should invest into operator-based solutions so that you can actually really make your life easy and take advantage of what the Kubernetes ecosystem has to offer.
Got it. And since this particular video is all about KubeDB, I mean, we'll come in the lab of actually now deploying applications through KubeDB. But before that, I also want to have your reflections on scalability of this operator. So what do you think? I mean, there is a single instance of this operator running right now, or the provisioner, let's say. How much does it scale up? How many databases can it manage?
I mean, you can easily manage hundreds of databases, right? And then if you are looking to scale beyond that, I mean, it is all configurable, right? Like internally, like, there are flags to essentially, like it's called like a runners, or basically it's like the coroutines in terms of actual implementation, how many you can run, so you can scale them up. And then if you're having like a lot of resources, you probably your API server, especially HCD, that's also needs to scale with that. So as long as you can keep scaling, there is really no limitation in terms of what you can do, right? But yeah, but the other thing that you should also consider is like the operational aspect of it, right? Because eventually everybody has to update their Kubernetes cluster, and what happens then, right? If you have a cluster with like thousands of databases, okay, now you have an interesting proposition, so yeah, so I would say running hundreds of databases is pretty fine, like pretty common. But if you're running more than that, please reach out to us. We will be happy to help and maybe work with you, see if how things work out there. Yeah.
Interesting views from Kamal. Let's go ahead and deploy Panopticon, which is the glue between KubeDB and Prometheus Grafana. And let's make sure that this goes rightly. As I said, the same license key of KubeDB can be reused. So we will go ahead and do this. Okay, so we are all set at this stage to take advantage of KubeVault and KubeDB. We will come back to this later on of setting up an example Grafana dashboard once we have the workload from a database standpoint. For now, I will skip this portion, move on to this portion. And this will be the context for our next video. We will say bye on this video, join you on the next one, where we will start to deploy the sock shop application. And in doing so, we will go over the CRDs of the sock shop application specifically with regards to KubeDB. Thanks, Tamal.
Thank you.